Hello and welcome back. So in the last video, we were able to configure the spectrum analyzer using the VNA's internal source as the input signal and port 2 as the spectrum analyzer. A couple of things to note with the spectrum analysis option is that any of the VNA port can act as the source or the receiver. By default, the spectrum analysis option will open as B2/1, which means port 2 receiver is acting as the SPA input and port 1 is driving. But if the customer or the user wants to use port 1 as the receiver, that can also be done using the normal VNA functionality. So in this case, you can see it's configured as B2/1, and you can see that port 1 is driving. However, if the user chooses port number 1 as the spectrum analyzer port, they can configure this to B1/1 and choose port 2 as the driver port. So if a customer has a 4-port VNA, any of the 4 ports can be configured as a spectrum analyzer port. For demo purposes, we will go back to the same settings. Coming back to the menu that you see at the bottom, we have channel number 1. We are into spectrum analyzer and VNA mode, where the start frequency is 19.9 and stop frequency is 20 GHz. With an RBW of 10 kHz, the averaging is off. For other settings, say suppose I want to change the frequencies, I can click at this area of start and stop frequency, and the software takes me to that menu. All the functionality which is available in the VNA mode is also available in the spectrum analysis mode, except few things like calibrations, which is not required. So for example, if we have to change the number of points, we can change the number of points from this menu. If I want to change the RBW, again by clicking on RBW tab here, it takes me to the menu where the RBW settings are available. It also has averaging per point or per sweep. Right now the auto RBW is on. The trace smoothing functionality is also available. For changing the view or VBW settings, either averaging or smoothing could be used. Let's see how that actually works. So right now the smoothing is set to 0%. If I say make it to 2% and I switch the trace smoothing to on, you will see that it basically acts as a video bandwidth filter. Turning it off brings the signal back as the raw signal. We could also switch on averaging, and averaging, say the factor is 10, and instead of per point, if you want to do per sweep, you would see that it again sort of acts as a VBW setting. Since we have configured the source as well, we can go to the power level. So port 1 power is -10 dBm right now. I have long cables that are attached together through a through with a through. That's why there are losses. But let's say assume I want to do 0 dBm port power. So you can see now, since the averaging is on, the power is slowly going up. You can also make use of the menus here, which are attenuators. So say suppose I want to attenuate the output power coming from port 1. Say I put it to like an attenuator of 10 dBm. And you can see that the power is going down. I put it back to 0 and the level should come up. All the menus for PowerCal, because when you are making S parameter measurements on a device, you have reference ports right at the input of the device. The same can happen with spectrum analyzer option also. Going back to averaging, let me switch it back to off, and there is no averaging. If I enable per point averaging, you will see that it helps in reduction of noise floor. Let me switch it back. We can also actually increase the number of channels. If I increase the number of channels to 2, you can see that we are now making S parameter measurements on channel 2 and spectrum analysis measurements on channel 1. And this is very useful because a lot of customers or users would want to see the S parameter and the output frequency is coming from their devices. We could have n number of channels open in this configuration. In the next video, I would be explaining more onto some math functions and other functionalities of the spectrum analyzer. Thank you for watching.